this is a heat map. As you can see, a heat map is a marvelous way of showing data. It's both a chart and a table. It's the best of both worlds. It has no real flaws. Even a big data set can work out well with a heat map because instead of printing the labels, you or the data here, as we've done, um, you can use tooltips. It's just marvelous, and it's relatively easy to do in D3. So the data we're looking at, this is the link. It'll be in the notes. It's total world population 1980 projected to 2050, and we'll be using this particular table here. So over we go to the code. So we're going to start the code from scratch instead of just redrawing it, because it's good practice, and I find that after a while when you're not typing it out you forget how to do it, and then where are you? So we've two functions in the code. There's draw graph that draws the graph, and then there's draw that triggers the draw graph function. Draw, inside your draw, which doesn't take a parameter, there's a D3 CSV promise, which is chained with a then and a catch. The catch tells us when something went wrong, and it logs the error to the screen, or to the console, I should say. And then in the then part of the promise, we have an accessor function, data, and we ask data, we send data as a parameter to the draw graph function. So we'll just run that and see how it goes. Launch terminal. Run the Python server. We've set the home screen on Firefox to localhost 8000, so it's always there for us. And there's nothing showing. The file isn't found. I go back. And of course, I haven't put in a URL in D3 CSV, which is a mistake. So we put in the population data that we were looking at earlier from the World Census. And we'll hope for more luck. And that's loading fine, except the population is coming in as a string. So we'll just change this to table because it's easier to read the data. And inside this, the then part of our promise, we're going to go data for each D. D population equals plus D population. Plus D is a D3 shortcut that says turn this into a number, because JavaScript reads numbers as strings by default. Okay, so our data is coming through successfully. And the last thing we're going to do now, we'll just shut down the terminal. The last thing we're going to do now is we're going to go into index and kill those hello YouTube placeholders that we've had since the start. Placeholders are dangerous, and really I should have killed them ages ago, but they're dead now, so we can march on. So I've noticed as I've been creating these videos that I'm inclined to forget to do things, and I have to go back, which I feel I'm letting you all down. Therefore, in order to discipline myself, I'm going to put in my comments first. So I'm going to write out a list of all the things that are included in a D3 chart, or this D3 chart in particular. They're mostly the same across the charts. There's the odd different chart that has different elements. Some have tooltips. This won't have a tooltip, for instance. But these are the elements that we're going to have to create one by one in this for this heat map. So I've written out all the titles, and I'm now commenting them out. Command / is how you is the keyboard shortcut for commenting in VS Code. So we're going to put in the headline using the same headline tool we've been using all the time, which is document get elements by tag name h2, the first element of that array, because it's only one h2 tag on our index HTML. And we're going to call this population, population growth by continent, or by decade. It should be by, it'll do, look, it'll do. Then H3, population given in millions. Because this is the easiest way to show millions. I experimented earlier as to whether or not to put in millions with the labels. It works better like this, I think. Okay, the dimensions are, well, we'll have a look first. We'll have a look if those headlines came up. It'll be horribly disappointing if they didn't, because if that part isn't working, we're in awful trouble. But they have turned up. Close the terminal again, and we create the dimensions. The primary dimensions are width and height. We then create a margin, which is an object with 4 keys. HTML measures when it's CSS, I should say, when it's going around objects, it goes in a clockwise manner. Hence, top, right, bottom, left. So that's the order that we're following here. Top and right at 10 are good defaults, 50 are good defaults for left and bottom, because that's where the axes normally are. They're not always, but they normally are. Then from these 3 basic measurements, we can create our plot height and plot width measurements, which we can then adjust according to our need later. That's why we create the plot inside of the canvas, to give us a little bit of overall control, meta control, if you like. So the plot height is the height minus the top margin and bottom margin. The plot width is the width minus the left and right margins, which makes sense. Then to create a canvas, we call D3 select all, or there's only one of them, we call D3 select ID canvas, which is the div with the ID of canvas that exists in the index file. To this we append an SVG, a scalable vector graphic. All of D3 is scalable vector graphics built one on top of the other, on top of the other, on top of the other. We're going to give it a background of Alice blue, very subtle sort of a blue, so that we can see it, but it doesn't overpower us. We're going to give it a height of height and a width of width. To this canvas, we're going to append a G division. G stands for group, and this is going to be our plot object that exists inside the canvas. And we're going to place the plot. We're going to call a transformation to translate the plot by, we're going to move it in from the left by margin left, and we're going to move it down from the top by margin top. We're going to use string interpolation to do that. Transfer, translate takes 2 parameters, an x and a y. And these are x and y parameters here, margin left and margin top. So if you want to move it down further, across further, you just have to change the margins. You don't have to go burrowing through the code like a small woodland beastie. So we'll just take a look. We'll just take a look at the code. We see that the plot is turned up as it should, and now we're going to move on and we're going to make some scales. So we're going to create scales. To create the scales, we create 2 helper sets. So we're going to get all the unique values for continent. Call them continent. And we're going to get all the unique values for year. So that'll be constant year is equals new set data map D year. I think it's year that they're called in the original data, when you're not sure, it's best to go back and look, because really um, it's not exhausting and the thing will come out right. Okay, it's here. So that's all fine. We can start creating our scales now. Both the scales, the X and Y scales, for a heat map are scale bands, which is fantastic because scale bands is a very easy scale to figure out, because of the bandwidth is always the same. It just makes it a simple scale just to fill in the bits. Everything adds up nicely in a scale band. So for the X scale, we're going to have continents in the X scale, and for the Y scale, we're going to have years. And the ranges then will be 0 to plot width, 0 to plot height. Now we need to create a scale color, and for a scale color we're looking at a new scale, which is D3 scale sequential. A sequential scale is something that runs on continuous data rather than discrete data, so that it will always find, if you have 1.1 and 1.2, it will find 1.11, 1.111, and so on. There's always further to go. So we'll use the extent constructor to get the domain. You'll notice that there isn't a range for scale color. For scale sequential, we use a method called interpolator, and we use one of the interpolated libraries that D3 in its goodness provides us with, and there'll be a link to the interpolated libraries in the notes below this. And the last, it's not a scale, it's a formatter. We'll just have a D3 format function because that's going to be useful later. Okay, we're going to create the visualization now, which follows the normal routine. Plot, select all, whichever type of SVG you're going to use, whether it's a circle, a rectangle, or a path. Here it's a rectangle. So it's select all data, enter, append, whatever SVG it is. Select all rectangle, data, enter, append rectangle. Then we give it a class attribute, and then we add 5 more attributes to contribute the 4 more attributes to create the actual rectangle itself. So you remember, an SVG rectangle is created with an X value, a Y value, a height value, and a width value. So we're going to provide all those, and then the last thing we're going to do is provide a fill value, which will use the scale color. Scale color will take the population value for each of the data. So to get our X value, it's going to be D maps to scale X, obviously. And that'll take continent, D continent, as its argument. The Y value, D maps to scale Y, which takes D year as its argument, because we set up the X scale to map continents and the Y scale to map years. The height is going to be the bandwidth for the Y scale, so it's scale Y bandwidth. And then the width is also going to be the bandwidth, but this is the bandwidth for the X scale. So fantastic, it's just so handy because you don't have to figure out what the heights are, as we had to do with the bar chart, which was stressful. So we've got all that going. We're going to open our terminal. We're going to run our server. We're going to launch the Fox. We're going to hope it works. And it works. There is our heat map. It's a bare bones heat map. So we're going to jazz it up a little bit now. And the first thing we're going to do is we're going to add the axes. Well, first we'll take a look at the actual rectangles, and that's a bit small. I'll blow it up the next time so you can see it better. But you see a rectangle with the XY height and width values that we expect. Okay, we're going to create the axes now. and the axes are the same as we've seen them before. So it's a regular formula for axes. We'll kill the terminal, give ourselves a bit of room, tidy this slightly. And then the x-axis is axis bottom, which takes the scale x. And the y-axis is the axis left, which takes scale y. So these are axis constructor functions. And then the axes themselves, x-axis will be, let x-axis equal plot append G. G stands for group, so that all the details of the axis are in one G division. And this group, we're going to transform it by translating it. And the translation here is 0 and plot height. So we're using an interpolated string, so we can read the plot height correctly. We're using plot height because we want it to start at the bottom left corner. We're going to give it a class of axes. And we're going to call our axis constructor function that we just created. And then it's the same thing again for the y-axis. So we'll just copy it, copy the x-axis, paste it, and change it so that x-axis becomes y-axis. We change the transform to translate, the transform translate to translate 0, 0, because we want this to start drawing in the top left down. And the function we call this time is the y function, y-axis function. Just add a semicolon there. Launch the server, launch the Fox. Reload the Fox, I should say. And here's our axes coming up, sweet as a nut. Okay, next thing we're going to do is we're going to add the labels, and we're going to tidy up the axes a little bit. So we're going to put the labels onto our heat map now. Let labels equal plot select all text. And a date, and then enter, and then append text. This is the standard formula that we've seen all through this series of tutorials. So once we've loaded in our data, we can give the labels a class. We'll call the class pop. And we need to provide an X and a Y attribute so that the machinery knows where to locate the labels. And we want to add a style to the labels as well, which will it'll give it a fill color. So this is just bare bones stuff now. Oh, a text element, of course, as well, to tell us what text to put in. And the text is obviously depopulation. An accessor function D maps to depopulation. And I'll just move this down, the comma formatter that I created, I'll move down under my formatter heading just to keep things nice and tidy. Okay, so we're going to run this now in the expectation it's going to work, but it's not actually going to work. I found this out myself maybe an hour ago, and it's very strange. Well, actually, I thought it would work a bit better than this. There's nothing showing at all, and the inspector shows us nothing. The classes are created, there's nothing else, and there's something the matter with the function. Select all text, data, enter, append text. That all looks fine. Uh, oh, I see what I've done here. In a slightly silly moment, I have forgotten to add the accessor functions to the x and y attributes, so it doesn't know where to locate the data. So the dx accessor is d maps to scale x d constant, and the y accessor is d maps to scale y d year. Should work now. Doesn't work. And I didn't put in an accessor for style. So I don't need an accessor for style because I'm just going to put in black just so the labels will come up. And what you notice is that the labels start down here. So it's missing the first 10 labels. And I have no idea. When I did this, I had no idea why the labels are missing. And I found a way to make them come back. And the way to make them come back makes no sense, but it works. Right? So that if you put your labels after you create the axis, the labels will not show. If you put in the labels after you create the visualization and before you create the axis, it all works fine. I've no idea why that is. There's no reason why that is. But, oh hell's bell, it's probably cached. Let me reload it. And here they are now. Right. So our labels are showing up, and for some reason, now the labels aren't appearing correctly, but the point I want to make is that if you put the labels after, if you create the labels after you create the axes, it won't read all the labels. I have no idea why that is. I presume it's a bug. You know, I don't think anyone would create that deliberately, but it's there and you have to allow for it. And D3 can be like that. D3 has these fiddly elements that you just have to either work it out, or if you're lucky, you see a tutorial like this, and I might have just saved you 3 hours. Okay, we're going to move the labels because obviously they're not showing correctly. So we're going to set a text anchor to end, and the reason we're using end is because these are numbers, and numbers generally are right aligned when we see them presented as data. And the way we're going to move the labels is that we're going to use the dy dx attributes that we saw before. Dy dx from calculus meaning move by a small amount. And the small amount we're going to move them is by half the bandwidth. So we're asking the system to move the labels across by half the bandwidth and down by half the x bandwidth and down by half the y bandwidth, the y scale bandwidth. And we'll see if that's any better. And it's much better because originally it was drawing the labels in the top corner where you can't see them. So this now centralizes them. The problem that we have now is that black is not an ideal color because we have different colors behind the labels. So one way that this can work, and it doesn't always work, but one way it can work is if you add a stroke to the label and give it a stroke width of 0.5, it just outlines the label enough to make it pop a little. And that kind of works, but it doesn't really, if we're going to be honest. So we're going to have to look at alternative solutions. So the alternative solution we're going to use is we're going to go to the CSS. So if you right click on the labeling inspector and go to copy and go to CSS path, and then if you open your style CSS file, paste the path, we could just get rid of this because there's going to be a tooltip, or I'm not going to put access labels in this. And that's not a path, that's a selector. Copy it correctly this time. Right click, copy, CSS path, paste in the path. And we're going to change the font family to Franklin Gothic Medium, which is more of a display font. So in font theory, there's reading fonts and there are display fonts. And Franklin Gothic Medium and Arial Narrow are more display fonts. We're going to make the font size 1.5 times the size of normal, which is what 1.5 rem is. That's not showing up. CSS is always slowest to reload. So that's looking a little better now, while still not looking amazing. So what else can we do? Well, we can move the labels a little further to the right. So instead of dividing by 2, we're now dividing by 2/3. Sorry, we're now dividing by 3 over 2, which is the same as multiplying by 2/3. And we're going to finally use our comma formatter to make the numbers bigger than 1,000 easier to read. We reload. Again, it's not great. The white stroke isn't really working. If we're going to be honest with ourselves, we'll just move these back a little as well. Okay, that's better. So there's a bit more room now for the labels. They're standing out a bit more, but they're not dominant. We're going to, the labels haven't gotten bigger, means that we have to change the axes labels, the text of the axes, which we're again going to do in CSS. I haven't copied the path to the tick text. And we're going to set the font size here to 1 rem, 1 rem. Kill it, relaunch it. So the labels aren't as dominated now by the axis labels aren't as dominated by the labels in the heat map. We're going to have to sort out the x-axis where you see the labels written over each other, but that's fine. We could deal with that. The heat map labels themselves remain a problem. So now that the stroke width change hasn't really worked, we're going to use our heads, and we're going to decide that the fill color of the label is dependent on, we're going to make it dependent on the cell that's behind it, the heat map tile that's behind it. So the heat map tile that's behind it is dependent on population. So we're going to create a ternary operator, and a ternary operator is an if then else operator. So what we're saying is, if the population is less than 2,000, fill these labels with black. If not, fill them with white. And this now is beginning to look a little better than it did. They still look a little hazy, and I'm not entirely sure why. And it's because I haven't deleted the strokes. So delete stroke and stroke width. Reload. And there we are. These now are proper readable labels. Now we had to labour at them a bit because that's what D3 is. You're going to spend a lot of time going over and back. You know, you're not going to get it right in one thing, and you're as well get used to it. Now, because the x-axis labels are long, we're going to rotate them so there's a bit more room. We've done this earlier with the bar chart, I think. I might have imagined it, I'm not sure. Anyway, it's a simple enough process. Transform, translate, rotate is the thing. There's no accessor function for this because we can figure it out with regular numbers by trial and effort. We'll rotate -30, and again we'll set a text anchor at end so it rotates from the end rather than the middle. So what we're asking the labels to do, the tick text here to do, is to swing down by 30 degrees. And we need to make the bottom margin bigger. Again, this is the beauty of having the margins accessible. Reload the Fox. And here's our labels appearing marvellously. So there's just one last thing we're going to do before we call it a day, in that you see those outer ticks at the end. You might remember when we were looking at axes first that we there was a tick size outer parameter we can call on the label, and these are the outer ticks, and if you set tick size outer to 0, those ticks disappear, and that's what we're going to do now. That's tick size outer 0, copy that, I chain it to the y-axis as well, reload, and they're gone, and it's just that little bit nicer. So this is the opposite half of D3, where your heart is broken because the labels won't, the first 10 labels wouldn't appear, right? That's what kills you. It's the little things like this that make quite a strong aesthetic difference to a chart, that make D3 worthwhile, and why you don't give up on it entirely, because it remains so very powerful as a means of visualization. Anyway, that's enough for today. I'm going to go to one tutorial a week instead of 2, because I just can't maintain the pace at 2. So next week we're going to be looking at stacks and stacked bar charts, and maybe, if everybody is really, really good, stream graphs. Peace and long life. Live long and prosper.